Now, this illustration deals with overcurrent protection in accordance with NEC 630.32A as an example. Now, to start with, this section deals with resistant welding. Now, let's review the information. An arrow is pointing toward the welder. The resistant welder's primary current value is 100 amps. The duty cycle of an operation is 40% duty cycle, the way the welder will weld on and off. Now, next, let's review the overcurrent device that's ahead of the branch circuit that's supplying the power to the welder. Now, notice the overcurrent device, the arrow pointing to it at the service equipment at the very top of the illustration. Circuit breaker or fusing, this percentage will work. And the maximum percentage is 300% of the FL current value in amps. And notice table 240.4G states that yes, you can size the overcurrent device greater than 125% of the welder's primary current, and size your conductors and overcurrent device at 125%. It would allow you in your table 240.4G to size the overcurrent device greater than 125%, and we're using 300% as you see. But again, we as electricians, designers, inspectors, whatever our job may be, we always would review 240.4G in that table to see if the equipment in that table requires inrush current values, and then we know we size the overcurrent device greater than 125% to allow equipment to operate. Now, and I'm talking about starting and operating or just operating. Now, the disconnected means is 630.32, and this basically says if the welder is not equipped with a disconnect, then you add a disconnect there within 50-foot bird's eye view, the way the crow flies, and route of travel, in accordance with Article 100, the definition of inside and inside. Next, we'll look at sizing the conductors in the illustration. 630.31A, and we're using PHHN copper conductors. Now, once again, if we want to review another section that goes into steps and provides text with additional information, look at the figure 9-11. So we would actually review Volume 1 of Stallcup's Electrical Design Book. We go to Chapter 9 and pick up the figure 9-11. Now, with this information, we're ready to just do a quick count. In the field, mostly you're going to have to determine the conductor's installation that you select to use, and then you go to the welder and pick up the information that's on the welder, like for instance, duty cycle, the primary current of 100 amps. And that's usually what an electrician does, and none of this other stuff available to you. You have to know in the code for that particular R sections that deal with your subject matter. Now, this is a good illustration just to do it quick and size everything. If you should come up on a welder, as you see in the illustration. Now, the quick count for sizing the conductors first. So we'd actually look at 630.32A2 and table 630.31A2, and we would find for 40% duty cycle, we would get a 63% demand. Now, depending on the type of welder, you can take 40%, take the square root of it, and you come up with your percentage, like 63%. And I think if you take the square root of 40%, you come up with 63% multipliers you see in sizing the conductor. So doing the math, 63% of 100, we come up with 63 amps. Now it's time to select the conductor, so we go to table 310.16, and we would select a number 6 that would be good for 65 amps for 75 degrees C permanent. Now, using the design book, just remember, everything is going to be 75 degrees C in most all cases without it says otherwise. If you're using cables, it usually be 60 degrees C or dual mark, as we talked about in Chapter 9 and 8. Now, we know the code allows in 630.32b as a void. The 300% can be used based upon the ampacity of those 75 degree C conductors from table 310.16. So 300% of 65, we come up with 195. We round it down to 175, and we could have up to 175 amp main on number 6 conductor. But notice you can always use a smaller size overcurrent device as long as the welding will function and operate based upon the type of welding task we selected the welder to perform. So figure 14-35 just simply deals with overcurrent protection or resistant welders in accordance with 630.32a to start with. Then you notice all your main sections are listed in this figure 14-35.